Alright, so let's take another look at a linear combination problem. And now we claim that this vector here, 7, 10, 16, 7, is not a linear combination of the following four vectors. And what we want to do is, again, rewrite this as a statement about vector equations, which is familiar territory, and then ask ourselves, is it true or false? So, let's go ahead and start with rewriting this as a statement about vector equations. So remember, what it means for a vector to be a linear combination of these is that we can find scalars for these vectors here, so that when we take the sum of the scaled products, what we achieve is this vector. And our claim is that this does not happen, right? And so if I want to rephrase this as a vector equation, what I'm essentially saying is that the equation, let's say x1, 2, 2, 2, 1 plus x2 minus 4 minus 2 minus 4, 1 plus x3 minus 1 minus 2 minus 4 minus 3 plus x4 minus 1, 2 minus 3 minus 2, that the claim that this is equal to 7, 10, 16, 7 does not happen, i.e. has no solution. So that's my claim, or that's what allegedly is happening here. Now, to verify whether or not this is a true statement or not, what we want to do then is take this vector equation and we'll see if it has any solutions, right? So, to which end we, as usual, convert it into its augmented matrix form. So let's go ahead and write down what that looks like. 2, 2, 2, 2, 1, minus 4, minus 2, minus 4, 1, minus 1, minus 2, minus 4, minus 3, minus 1, 2, minus 3, minus 2, augment 7, 10, 16, 7. Alright, so that's my augmented matrix form, and I want to find its reduced row echelon form. So we'll break out technology as one does in such cases, and so let's go ahead and enter in 2 minus 4 minus 1 minus 1, 7. That's my first row. And then for my second row, 2 minus 2 minus 2 to 10. Third row, 2 minus 4 minus 4 minus 3, 16. 1, 1, 3, sorry, minus 3, minus 2, 7. Alright. And so we have our original matrix here, and then a reduced row echelon form here, which I'm just going to write out. One zero 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 0 1 0 0 0 0 1 0 0 0 0 1, and followed by minus 5/8, minus 11/8, minus 7/2, 3/4. some observations here. First, I'm really glad I didn't have to solve this by hand, right, or use Gauss-Jordan in order to find this particular expression. But there we go. But at the same time, what this is telling me is that, hey, there is in fact a solution to this, right? What we're seeing is that x1 is, if I let x1 be minus 5/8, x2 be minus 11/8, x3 be minus 7/2, and x4 being 3/4, then that in fact is a solution. I can go back here and say 5/8 minus 11/8 minus 7/2 plus 3/4, and I were to work that all out, that would be 7, 10, 16, 7. So there is a solution to this equation. Our vector 7, 10, 16, 7 is a linear combination of the other vectors. I won't write them now. And so the original claim is false, right? Because what original claim was that this vector 7, 10, 16, 7 was not a linear combination of the other vectors, which what we just showed was that it was, because there is a solution to that vector equation. All right. Thank you very much.